Hello students, welcome back to the lecture series on discrete mathematics. We are learning techniques of counting and this is video part 4. In the previous lecture, we have already seen the basic counting principle, the inclusion exclusion principle, permutation and combinations, and now in this lecture we are going to understand about the pigeonhole principle. This is the last topic of techniques of counting. Let us see the concept. The pigeonhole principle. Suppose that a flock of 20 pigeons flies into a set of 19 pigeonholes to roost. Since there are only 20 pigeons and 19 pigeonholes, at least one of these 19 pigeonholes must have at least 2 pigeons in it. To see why this is true, and note that each pigeonhole had at most 1 pigeon in it, right? And at most 19 pigeons per hole could be accommodated. This illustrates a general principle called the pigeonhole principle, which states that if there are more pigeons than pigeonholes, then there must be at least one pigeonhole with at least 2 pigeons in it. Of course, it is not just related to the pigeons and the pigeonholes. We can apply this to other objects also, and we can solve a category of problem using the pigeonhole principle. So let us see the rule first, the principle. If k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. So the objects we are taking as the pigeons and the pigeonholes we are taking as the boxes. That means we have at least one box will be there containing 2 or more of the objects. This principle was first stated by German mathematician Discrete, hence it is also called as Discrete-Rod principle. Let us see the example, how we are going to apply the principle. Since it looks very simple and it looks very obvious, but let us see how we are going to apply this on the circumstance or on the situation. Now let us see the first example. Among any group of 367 people, there must be at least 2 with the same birthday because there are only 366 possible birthdays. So here, just think about the boxes and think about the objects. So the objects are, the objects are 367. And what are the boxes? Since we are talking about the birthdays on the same day, and in a year there are maximum, if it is a leap year, there are 366 days, otherwise we have 365 days. So the 365 days of the year are the boxes and the 367 people are the pigeons or the objects. So even if you have 365 or 366 boxes, and 366 people will have birthdays on different days. It may happen, but the 367th person will go to the box in which already we have one object already. So that means there are at least 2 with the same birthday. So this at least word is also important. It is not always the case that we have 2 people only. We may have 3, 4, 5, 6. But the possibility, or we can talk about at least 2 with the same birthday. Now the second example is, in any group of 27 English words, there must be at least 2 that begin with the same letter. Now let us decide what is the box and which are the objects. Now there are 27 English words. That means these words are the objects, and let us talk about the boxes. For example, we have 26 boxes of the English alphabets starting from A to Z. So if the word starts with A, it will go to the box A. If the word starts from B, it will go to the box B, C, okay, till Z. Since there are 27 English words, there is one object extra. And according to pigeonhole principle, that will go to any of the 26 boxes in which a word is already there. So that box will contain two words, and here we can finally say that we have two words, at least two words that begin with the same letter. So there are 27 words which are the objects and 27 alphabets in the English, the boxes. We have also the generalized pigeonhole principle. We have the generalized pigeonhole principle also. Let us see the statement. If n objects are to be distributed in m boxes, n is strictly greater than m. That means the objects are greater than the number of boxes. Then at least one box contains integral part of n minus 1 by m plus 1, where this notation is given the greatest integer not exceeding x. So this here in the generalized pigeonhole principle we can say exactly that how many extra objects are there in a box. So suppose any group of 367 people are there, there must be at least two persons with the same birthday. Since 367 minus 1 divided by 365 will be 1 plus 1 is 2. So in the example number 2, let us see how we can apply the generalized pigeonhole principle. Among 100 people, find the minimum number of people born in the same month. In the same month means months will be the number of boxes. So m is number of boxes, which is equal to number of 1, number of months, which is 12, and we have the total number of objects we have, that is 100. Now by generalized pigeonhole principle, it is not just about at least 2. We are going to get the exact number, that how many people will be having born in the same month. So it is 100 minus 1 by 12 plus 1. So 100 minus 1 is 99 by 12 is 8.25. The integral part is 8. So therefore there will be 9 people who have born in the same month. Let us see the next example. How many friends you must have to guarantee that at least 10 of them will have birthday in the same month? So just think about n or m. N is the number of friends which we have to find, and m is the number of months, which is 12. So here we want to find n minus 1 by m plus 1, which is equal to 10, because we are given the number 10, that is the answer. By generalized pigeonhole principle, that will be the answer. 10 minus 1 is 9, then into 12, and then plus 1. So I leave it to the students to solve this and tell me the answer in the comments. Thank you.